Hello and good day. Welcome back to our class. This is teacher Onin de Guzman, and our topic for today is factoring sum and difference of two cubes. Perfect cubes are numbers or expressions that can be expressed to the power of 3. Say for instance I have 27 x to the 6th power. There are two things that we need to manipulate. The first one is the coefficient 27 and the variable x to the 6th power. The coefficient of 27 can be expressed as 27 is equal to 3 times 3 times 3 or 3 to the third power. On the other hand, x to the 6th power can be expressed as x squared to the third power. Now, take note that if we will apply the power rule of the law of exponents such that if I had a raised to n times m raised to n, this can be expressed as am raised to n. So naturally, if I have 27 x to the 6th power, this can be expressed as 3 to the third power times x squared to the third power or 3x squared to the third power. For the benefit of our discussion, factoring sum or difference of two cubes is composed of binomial and trinomial. So let's talk about first the sum of two cubes. So if I have a cube plus b cube, this can be factored as a plus b times a squared minus ab plus b cubed, such that this is a plus b is the binomial and a squared minus ab plus b cubed is the trinomial. On the other hand, if I have difference of two cubes, so if I have example a cube minus b cube, this can be factored as a minus b times a squared plus ab plus b cubed. So let's consider problem number 1. So say for instance, factor y cubed plus 27. So the first thing that we will do is get the binomial. So that is, get the cube roots of y cubed and 27 respectively. So what we have is cube root of y cubed is equal to y, while the cube root of 27 is equal to 3. So therefore, in the binomial, we have y plus 3. Next, for our trinomial, so what we're going to do is square the first term of the binomial, so such that we have y squared is equal to y squared. Next, get the opposite of the product of the first and the second terms of the binomial. So this is the first term and this is the second term. Multiply y times 3 is 3y and get the opposite is equal to negative 3y. And finally, square the second term of the binomial. So the second term is 3. So we have 3 squared is equal to 9. So therefore, we can say that the complete factored form of y cubed plus 27 is equal to y plus 3 times y squared minus 3y plus 9. So let's move on to our problem number 2, factor 8x cubed minus 64. So the first thing that we will do is get the greatest common factor. So the greatest common factor of 8x cubed and 64 is 8. So what we have is 8x cubed divided by 8 is equal to x cubed. 64 divided by 8 is equal to 8. Take note that this is the difference of two cubes. So we can express this one or we can factor this. Okay, so just copy 8. Take note that I can get the cube root of x cubed, which is equal to x, that we have here. Cube root of 8 is equal to 2. So this is the factor for our binomial. For our trinomial, so what we're going to do is square x. So x times x is equal to x squared. Next, get the product of x and 2. So that is 2x. Okay. Make sure that this is the opposite. Okay, so that is why we write here plus 2x. And finally, for the last term of the trinomial is square 2. So we have plus 4. So therefore, the final factor or the complete factor form of 8x cubed minus 64 is equal to 8 times x minus 2 times x squared plus 2x plus 4. Let us consider problem number 3. Factor 27 to the 4th power minus 8m to the 6th power. So the first thing that we will do is factor the greatest common factor. So the greatest common factor is actually m. Then we have 27 to the 4th power divided by m will give us 27m cubed, while 8mn to the 6th power divided by m will give us to 8n to the 6th power. Notice this is actually difference of two cubes. So let's move on to further factoring. So just copy m. Then, for our binomial, get the cube root of 27m cubed, so that is 3m, while the cube root of 8n to the 6th power is 2n squared. Since this is negative in the binomial, this is also negative. On the other hand, for our trinomial, for the first term, we will square 3n. So it will result to 9m squared. Next, the middle term of the trinomial is the product of 3m and 2n squared. And get the opposite, so that is why positive. So take note, if this is minus, the middle term of the trinomial should be positive. And finally, negative 2n squared will give us positive or plus 4n to the 4th power. So therefore, so the complete form of the given uh, binomial 27m to the 4th power minus 8mn to the 6th power is equal to m times 3m minus 2n squared times 9m squared plus 6mn squared plus 4n to the 4th power. So let's move on to problem number 4. Observe that we have actually the sum of two cubes. So there's no greatest common factor except for 1. So we will go directly to factoring. So on binomial, get the cube root of 1 as well as the cube root of 27n cubed, which is equal to 1 and 3n respectively. Since this is sum, so we will write in the binomial as sum. For our trinomial, we have, okay, the first term of the trinomial is square 1. And the middle term about the trinomial is the opposite of the product of 1 and 3n, which is 3n. And finally, the last term of the trinomial is the square of 3n, or 3n times 3n will give us positive 9n squared. So therefore, so the complete factor form of 1 plus 27n to the 3rd power is equal to 1 plus 3n times 1 minus 3n plus 9n squared. Let's move on to problem number 5. So factor 5p plus 40ph to the 3rd power. So observe that we can factor this one using the greatest common factor. So what we have here is simply as 5 times p as the greatest common factor. So therefore, 5p divided by 5p is equal to 1, and 40ph cubed divided by 5p is equal to h cubed. So notice this is the sum of two cubes. So let's factor this one further. So just copy 5p. So for the our binomial, get a cube root of 1 and get a cube root of h cubed respectively. So since this is plus, so we will write here 1 plus h. On our trinomial, so the first term is the square of 1. So 1 times 1 equals 1. The middle term is the product of 1 and h and get the opposite. So we come up with negative 1 h or negative h. And finally, we have here h times h is equal to h squared. So therefore, we can say that the complete factored form of 5h plus 40ph cubed is equal to 5 times 1 plus h times 1 minus h plus h squared. So that ends our discussion on factoring of sum and difference of two cubes. Again, this is teacher Onin de Guzman. Do not forget to subscribe to my channel so that you will be notified about my new videos. Thank you.